everyone. Thank you for joining. This is the Oracle Machine Learning Office Hours. Today we're going to do a hands-on lab on Oracle Machine Learning AutoML UI. I'm Marco Seracibia, and Sharon LaMonica and Mark Hornick are on the call as well to support us. And the idea today is to take a look at the OML user interface for AutoML for model building and model deployment. The expectation today is to help you guys test drive the feature. The feature has been available since earlier this year. It is available with the Autonomous Database. We are going to explore a few of the different aspects of AutoML or Automated Machine Learning model building, and we're going to check how that interacts with our in-database machine learning models. We're going to build models and deploy them. We're going to deploy those models to OML services. And we're going to see how to auto-generate OML4Py notebooks that can build the models that you select, right? The top models, the best models you get. And also we're going to learn about the other possible integrations, right, with other apps. The expectations will be that for this 90-minute, it's really to get you guys familiar with OML AutoML UI and hopefully get you self-sufficient with the Live Labs environment as well on how to get in there, how to get an assignment, and how to run the entire labs there. So we're going to focus on AutoML UI. We are going to use other components from OML, including OML4Py and OML Services as well. And this current series of labs is not really an introduction to machine learning. So if you wanted to learn more about Oracle Machine Learning or machine learning itself and how that applies, we have a 101, 102 session available at the Ask Tom as well. So the link is going to be below. So we're going to start by accessing our Live Labs instance. We're going to check a quick introduction to OML AutoML UI. We're going to look at the lab overview. We're going to work throughout the labs, and then we're going to be ready to answer any questions you guys have. The main components here are going to be that if you have any questions, you might ask them on a Q&A. But if you need a lab help, if you have any technical trouble, then it's probably easier to chat to the panelists, okay? Also, by the end of this section, when I finish the Live Labs, Sherry is going to put it in the chat a link to these exact slides so that you guys can follow along, right? So if you get lost, if you get distracted, if you are not following everything, you're going to be able to catch up by looking at the slides and following the step-by-step there, okay? I see one question whether you need any required skills, and hopefully not. Ideally, you would have an idea of machine learning, right, and understanding of what we're trying to achieve. But I'm going to take you through the steps, so hopefully that's going to be an easy place to follow. Okay. So let's start by getting you guys access to your Live Labs instance. Okay. The first things we need to check is whether you guys already were running any instance. So if you had, before joining us right now, right? If you were using Live Labs, or if you have a reservation up and running, you will need to click on the trash can in your My Reservations tab. You're going to need to cancel that, because if you don't, and if you try to start our Live Labs, you're going to get an error like the one you see in the bottom, where it's going to say, hey, you can't have more than one Live Labs running, right, at the same time. So if you do have that, then please go ahead and click on that delete, okay? Otherwise, please go to this link. So Sherry, if you can please share that with the folks, the link to the Live Labs in the chat. So Sherry is gonna share right now the green button link. And what you guys want to do is you want to go to that screen, follow that link, and then click on that green button that says Reserve Workshop on Live Labs. Okay. And I'm gonna follow along so that you guys can see what I'm doing as well. Okay. So we're gonna come here and click on Reserve Workshop on Live Labs. Okay. Now, you are going to need an Oracle account, right? An oracle.com account. That account is free. So what you guys are going to do is, if you still don't have an oracle.com account, in that menu that I just showed you, you want to click on create account at the bottom. Okay. So if you don't have your account that you can enter user and password, you're going to have to go down there and click on create account. In the create account, you're going to enter the information, basically email address, give yourself a password, put your information, all the required fields, right, that are needed, and then you click your button create account. Okay, and then it's going to say, okay, I'm going to send that information to your email. So in the email, you're going to need to verify your email to use your account. So with that, in the next step, hopefully, you should receive an email pretty quick. And then when you get your email about the account, you go in there, click on verify my email address, you get a success, and then you go back to the screen that you were before, okay? Then we need to go back to that link, click on the Reserve Workshop Labs, and now you enter your user and your password. So I'm assuming if you didn't have an account, you were able to create it. Again, don't worry if you fall behind. We're going to share with you guys a PDF, right, with all of these steps. So the idea is then, now that you have your account and you're logging in, what we want to do is we want to click on make sure to start workshop now, right? So make sure that that is on, and then give it a check on the I consent to receive the reservation emails. And then you can click on submit reservation. Okay, I'm going to do exactly the same now. So I'm logging in. And now I'm going to say consent to receive reservation emails and just submit reservation. Okay. Now that that reservation is getting prepared for you, let's click on view your reservations. And now here on the top, this reservation is still starting to get prepared, okay? So this is the time that you started the reservation, and then it's gonna show up here, the status, okay? When this is completed and at the point that, that it's going to be available. It usually takes some 15 minutes. So I'm gonna put some 15 minutes here for us, and then we're gonna come back here and check it out, okay? When it's time. Now that you guys clicked on that and have that reservation running, then we're gonna wait, okay? And then we're gonna let this guy do its thing, and then it runs, right? Normally it's like 15, 10 minutes depending on the day. It could be as high as 20, but we're gonna come back here, okay? So let me run a quick video introduction on what AutoML UI is all about, and then we'll continue.
The machine learning process has multiple steps. While some don't readily lend themselves to automation, others increasingly do, especially those that are repetitive and iterative. Take the modeling process. You have multiple algorithms to choose from, but which is best? So we choose an algorithm. We build a model. We tune it, hopefully to improve model quality, and then compare it against previous models, and repeat with the next algorithm. This trial and error approach is expensive, both in terms of time and compute resources. Oracle Machine Learning AutoML UI provides a no-code user interface that automates this machine learning process. How easy can we make it? Define your business problem, prepare your data, then just specify the data table and target you want to predict. OML AutoML UI does the rest to produce several models for you to consider. Select the model you want to deploy through a REST endpoint, or immediately through SQL queries for custom enterprise applications, Oracle Analytics Cloud dashboards, or Oracle Apex applications. With Oracle Machine Learning AutoML UI, you get productivity for data scientists while empowering non-expert users within database machine learning. Learn more at oracle.com/machine-learning and take OML for a free test drive in Oracle Autonomous Database.
Right. So again, while we wait, we're going to go into an introduction on AutoML UI. And again, if you're just joining, we're going to share with you guys a PDF with instructions. So Sherry, if you can put that in the chat. So you guys can click on that and then see the PDF with the current instructions that contains all the slides that you guys are seeing here today. So you can follow along and you can check the step by step, okay? So Oracle Machine Learning AutoML UI is part of the Oracle Machine Learning family. So we have, on the left-hand side, you see the different interfaces for the different languages that we have. We started with SQL, and then we went to R, and then we went to Python. So we have those three capabilities there. On the right-hand side, you see the portions that are working on the more on the UI side, OML Notebooks, which we're going to see today, and the Oracle Data Miner, right? That's a SQL Developer extension as well. And then we can see Oracle Machine Learning for Spark, which actually works on the big data service itself. But then at the bottom, the latest additions, the Oracle Machine Learning AutoML UI, which we're going to see today, and the Oracle Machine Learning Services, which we did last week. So basically, the idea is the Oracle Machine Learning, we have a few key attributes, right? So try to automate things, try to do things scalable, and try to make them production ready. And then AutoML UI is definitely going to help us with the automated side of the house. So let's take a look at what that means. We are basically looking into the Oracle Machine Learning Notebooks, and this is our main interface. We're going to go and into the interface here. This is basically a collaborative UI. It's based on Apache Zeppelin. And the idea supports everyone, right? You can be a data analyst, you can be a data engineer, you can be a SQL person, you can be a Python person, and coming soon, you're going to be able to be an R person, or coming later in the year, I would say. Then the idea is that all of these different languages and can combine their power into our main environments. So AutoML UI basically simplify the process of building models, right? So the idea is you have your data, right? You have your data prepared and curated, right? And then you have now the information you want, and then you have a target in there, right? One of the columns in the data set is your target, what you want to predict. So what we do is we go through all of these phases. We go through an auto algorithm selection. We're going to identify these of the in-database algorithms, the ones that we have, what's the best algorithm that matches your problem. Then we have an adaptive sampling phase where we're going to identify the right special sampling, right, for that data set, and then balancing the data the way we need. And then we have an auto feature selection, which is we're going to then at that point say, you know what, you have 300 variables, but actually of these 300, there are 10 that are the most important. So all the rest is just noise, right? So you don't need those. And then finally, we get to auto model tuning, which is now, let me improve the accuracy of that model by, you know, the slightly minor changes that I need or adjustments that I would give to this model, right? And at the end of the day, you have also a feature prediction impact that we're running. So we're ranking all the features to the most influential for the scoring itself, right? So then the idea is that it's a no-code, again, AutoML-based user interface. So you're not have to do any coding. It is a complete UI, and we're going to go through it so you can check and see the different stages there. But it's really a very minimalistic and lets you customize things later, right? So it is available in all Oracle Machine Learning notebooks and interfaces inside the Oracle Autonomous Database. So any Oracle Autonomous Database can have an AutoML running, including the always free ones. So it's going to always be there, so you can check it out. And there are a few comparisons here because OML4Py also has AutoML, right? It comes from there in the code, and that you can code. But normally what happens there is in AutoML UI, you actually have everything automated for you. In OML4Py AutoML and the API itself, you have the option to use or not a few of the different elements there, right? Before you get to your ideal model. And because there are slight differences there, but the idea is that the most of the component is the same, right? Then I actually added one of the exercises with it for you guys. So we're going to check AutoML UI. And then closer to the end of the session today, we're going to actually go into the notebooks and then use them directly there and check the Python notebook running, okay? So basically the performance considerations, I mean, the session we're using today, the live labs, is 2 OCPUs and no auto scale. So it is not intended for you guys to run any large production jobs, right? The idea is to illustrate the functionality on small data sets, right? There is, again, as I mentioned before, the always free tier. It's going to be a 1 OCPU. And because it has only 1 OCPU, it does not have any parallelism available for the AutoML. So when you run them in there, you're actually going to have to be more patient, right? Because then it's going to be checking the different models one by one, right? Instead of using parallelism for that. And then, of course, in the pay tier, you can configure, any sizes there, right? Very large machines with a very large level of parallelism. So the experiments then, at the right-hand side, you see we have some defaults, right? So we're going to see the defaults. Basically, there are 5 top models, and all the algorithms are going to be selected. The default is to be selected as a low database service level. We're going to be changing that and playing with it. And there's a default of a time limit for 8 hours, right? Which should be probably enough, depending on the size of the problem you're trying to solve. But no, don't worry, today's problems, they're going to be running in 2-3 minutes tops. So to reduce the runtime, we're going to be allowed to choose the faster results. There's a better accuracy as well, but today we're going to be using faster results just to finish soon. And then we want to reduce the number of top models to maybe 2 or 3. And we're going to eliminate some algorithms of not interest. That is a possibility as well. And if you're on paid tier, you can increase the database service level, which is actually what we're going to do. So the expected workflow then is basically a person receives like a CSV file, right? Data from somewhere. You import that data as a database table. And then you can use any of these different tools that we have available for you to manipulate the data, prepare the data, right? And then once you have that prepared database table, then we proceed into OML AutoML UI. And then at that point, you're going to be able to deploy in database models. You're going to be able to generate notebooks as well, and then build an in-database model and export it directly, or get from there to an in-database SQL scoring, right? If the application supports that. And then we can do a straight in-database SQL scoring as well, right? From, again, enterprise applications, right? Any applications that can connect to the Oracle database and the Oracle Autonomous Database, right? And at the end of the day, things like Oracle Analytics Cloud, for example, would actually be able to see directly inside OML AutoML UI results as well, okay? So let's check. I mean, it's been probably 12 minutes since my environments was requested. Have you guys received the environment and the emails? Make sure you check your email and refresh it, right? The browsers, because we want to make sure that you guys, that console, right? Your reservation is ready. So I'm going to go into mine. If you got yours, you're good. If you have not gotten your environment yet, please share that information in the chat, okay? So share that information in the chat and please tell us, hey, it's still not working for me, or I have not gotten my environment yet, okay? So basically in the my reservations, the idea is that if you can refresh, right? That's what we want to do. We want to keep refreshing until you see this. So now mine says available. So I can then click on launch workshop. Okay. So this is the page I want you guys to be on. All right. So you guys, I want you guys to be on this workshop page now. So remember again to refresh that page, the My Reservations page, because even though it might say, hey, it's going to be ready in 10 minutes, it might be ready already. Okay. Perfect. So again, keep refreshing it, from time to time. And if you got any errors or any problems, we're going to be able to help you out as well in the chat. We can check your session and then help you out with that. Okay. Let's take a look now at what you guys are going to see, right? So even though the My Reservations page might be saying a little more time, remember that you got to check the email, right? Check your inbox. It's going to have something like this, right? The environment is ready, and then it's going to tell you, start your workshop by visiting the My Reservations page, right? Again, guys, if you got there and you refresh it, and hopefully you got that information done, then what we're going to see now is something like this, right? So you saw that it was ready, and then when I got launch workshop, I got to this page, right? And from this page now, don't click on the launch console yet, but we're gonna need to see this page running. Okay, we're gonna do that next. All right. So what are the labs then for today? Basically, these are the labs. Okay, the first lab is basically just getting access to the notebooks and then create your first model using OML AutoML UI. Then we're going to create an auto-generated OML notebook, okay, from that model that we create. Then we're going to learn how to deploy that model to a REST API. Then we're going to create a second experiment, this time with more models and with a recall model metric, which is different than the original one that we're going to use, which is balanced accuracy. And then lab 5, we will run AutoML using OML4Py, just as a comparison, just so you guys have a feel for how that works. And then at the end, if we get time, I have a bonus section, which is using Postman to access OML Services REST APIs to score the model that you just deployed. Okay, so we're going to try to get through all of these. If we don't, again, I encourage you to download the PDF and then use that at your own pace at home so that you can learn how to use all of these tools. Okay, let's take a look at how to access the notebooks and create our first model. So first things first, you guys probably clicked on the launch workshop. If you're on this screen, then remember that the first thing we're going to do here now is click on this copy password. Okay, and then we're going to launch console. All right, so I'm going to do the same thing here. I'm going to click on the copy password, and then I'm going to click on launch console. Right, so here it already pre-populated my username. Don't change it. We only need you to click on the password and you paste the password that you were just given. Okay, and it's going to ask you to change it, but I'm lazy, so I'm just going to paste it 3 times here, the same password, right? Just so that I don't have to remember it again if anything happens to it. Okay, so again, step by step, click on that copy the password, click on the launch console, and this is how we're going to do it. You want to make sure that you paste the copied password there, click on sign in, change the password, probably copy paste it 3 times here, which is fine. We're going to then click on the hamburger menu in the main OCI screen on the top left here, and then we're going to choose autonomous database. Okay, so if I go here, then I'm going to click on this hamburger menu here on the top, and then I'm going to select autonomous database. Now it's saying, okay, I don't have any autonomous databases on the root compartment. Yes, so on the root compartment we don't. But what I want you guys to do is we're going to go into our specific compartment. Find your compartment. Your compartment, it's the name of the compartment is right there. It's basically your username dash compartment. So we're going to find it so that when we find it, we're going to see the autonomous database indicated right here. So if you go back to this screen, you have this compartment. So mine is 5788. You guys are going to have your own, right? So you go, if I go back to this page, I can expand this guy and click on the plus sign next to the Live Labs and look for my 5788 compartment. And now it's going to show my autonomous database right here. Okay. If I choose a compartment of someone else, it's not going to show up here. Okay. This is the compartment I have the rights to. So I can see I have 2 OCPUs, all right, available for this guy. So I'm going to click on that autonomous database to go into my autonomous database page, right? I'm in the autonomous database main page now. And what I'm going to do now is I'm going to click on the top on the Service Console button. Then on the left-hand side, after I click the Service Console, I'm going to click on Development. And then I'm going to be able to see the OML Notebooks. Okay, so back here again, I will click on Service Console. It's going to open up another tab with the Service Console. I'm going to be able to click on Development here. And then inside the development, I have one of these tiles here. One of the tiles is Oracle Machine Learning Notebooks. So you click on it, okay? And now you get to this page. So now that we got to the Oracle Machine Learning Notebooks sign in, everyone uses the same user and password, okay? So we're gonna go OML user. That's the name of your user. And the password is the same for everyone. So Sherry, if you can put that in the chat so that people can copy from there. We want to use OML user, all caps. And then the password is AA in caps, and then BBCC123456. Okay. So here's OML user, and the password for everyone is AABBCC123456. Okay. Great. So right now we are in Oracle Machine Learning Notebooks. All right. So you guys should be able to see that. And inside the Oracle Machine Learning Notebooks, once you log in, we want to click on AutoML on that button there. So I can click either here, or if I go to my hamburger menu here, AutoML is also available there. Okay. So either way works. So we're going to click on AutoML here. And then we see that we have no experiments, right? Basically in AutoML experiments, there's nothing there, right? We don't have any available experiments here yet. So what we want to do then is create an experiment. So I want you guys to click a button here and create experiment. Okay. So what we want to do again in the menu here is click on create to create the experiment. Give the experiment a name. Let's call it first AutoML experiment. And then let's click on the loop to search for a data source for our experiment. So I'm going to call it first AutoML experiment. Okay. Then I'm going to go to my data source. And the file that I want you guys to pull in is the SH. Okay. So you click on the schema called SH. And I want you guys to scroll down here in the menu and then click on supplementary demographics. Okay, this is the table we're going to use today. And then when you do, you click OK. So basically, this is what's happening, right? We're going to click on the schema SH, click on the supplementary underscore demographics table, and then click OK, right? And then we're going to get to this screen here. So let's go step by step in there. So all we did so far is we added that table, and that table shows up here. So we see what are the columns available, right? So the model doesn't know anything about that table. It only knows these data exist. These are the columns. These are the basic statistics, minimum, maximums, how many distinct values, right? So these are basic statistics about that data. So what we want to do is select a target. What is our target? In this case, this table contains data from information about customers, household size, education, occupation, years of residence, but it also contains one of the columns that we want to use as a target, which is the affinity card. We want to make sure that the model sees that column as target so that we can find more customers that have a high likelihood to accept my card and my offer. So we can click on that affinity card. That's what we're using to predict, okay? Now, because this is a numerical variable, our model immediately switches and detects actually that this is a numerical variable with not many different levels. So it's going to say, okay, this is probably a classification model, right? We can have a classification or regression, but the model is smart enough to understand it's a numeric, but I know that there's only two distinct values, right? So this is definitely a classification problem. Okay. Now, if we then select the case ID, then we can say, okay, customer ID is unique. So I want to select that as my case ID, right? So if you scroll down, you're going to see that that is selected here. You can see now your affinity card has a target on it. And that customer ID, because it's a unique identifier, is not selected, right? You cannot select that as to use that in the model, right? If you had other columns that you did not want to use, you could uncheck them as well, right? Now, see that we even support text mining, right? So we're going to do an automatic text processing on these comments here, right? So this is a varchar, right? So there are comments in that data. We're going to actually be able to looking at those comments and then separating people by whatever they say as a comment to our product, for example, okay? Now, because this limited time today, we wanted to make sure that we adjust a few things. So click on the left-hand side here in the additional settings. There's a little arrow here, right? You click on that little triangle, it expands the additional settings. So if you look at the additional settings now, you have maximum top models. We want to reduce that to 2, just so that we make it a little faster. Database service level, we want to increase that. So medium or high, because each of us is by themselves on this, we're going to select high, okay? And then a model metric, we're using balanced accuracy, which is the default. But you know, these are the options that you can choose as well. Also, the algorithms, you can, if you wanted to reduce the number of algorithms that are going to be tested for your problem. We don't need that because it's really, in this case, it's fast enough. So let's go back up all the way to the top. And now we're going to click on Start. And in this case, we're going to go faster results. Okay. And you can see that your experiment's going to start. Okay. So this is saying this experiment is running, right? So if you go back here, these are the choices we did. Affinity card is my target, my predict. Case ID was cust_ID. I opened up additional settings, put 2 maximum models, and I changed to high here, right? You can put medium as well. Those 2 have parallelism. And then we clicked on Start, and then we clicked on Faster Results, okay? So now, to check the progress, we're going to click on the 3 dots, and then we're going to see the progress, okay? So at the top of the screen here, under the running here, there are 3 little dots. We know it's not obvious, so one of the feedbacks we have gotten over many people is, please, can you change this to something that can indicate that you can click on it, right? And open a progress bar. So we are, as always, gathering feedback, right? This is showing you the progress. So I can see on the left-hand side here, I can see the balance accuracy changing, right? And then I can see that the 2 models were selected here on the algorithm selection, were a naive Bayes model and a GLM model, okay? And then now it ran through adaptive sampling, it did feature selection, and now it's on the model tuning phase. So now it's tuning the naive Bayes model, and it's showing me the balanced accuracy. It now switched to GLM and is now tuning the GLM model, okay? And at the end of the process, it's going to run the feature prediction impact. Okay, and again, if you guys are joining now, remember that you can always look in the chat for the zip file with the instructions. which contains everything that I'm doing today. So you can even, you have time to go back there and follow the instructions to catch up with us, okay? Well, that's done. So we can see that in that process now, it says completed here on top. You can close the progress bar, and you can always open it again. If you click on completed, it's going to show you the steps that it did, okay? All right, so now we have our two models. And what we want to do is we want to select on these models, right? After they're done, then the checkboxes will show the completed steps, right? And then the top algorithms, as we mentioned, were indicated. When it's done, you got the checkboxes there. So now we scroll down. Let's go scroll down and take a look at what happens here, right? So if you scroll down to your screen now, you're going to see that what you have here now is actually a set of importance, which was not there before. Now we have this new column called importance. And again, be careful the way you're scrolling, right? Because there's a scroll inside the scroll, right? So there's a scroll here, and then there's a scroll outside, right? So in the scroll inside, you can check here that what it's telling you is that the algorithms, actually before the algorithms, we run just a global importance for evaluating the impact that an attribute can have on that target, right? So this is a one by one, we check the attributes, and we estimate that they have a certain importance level between 0 and 1 on the overall target, right? On the impact on the target. This is not using the models themselves. This is just looking at the data and saying, okay, I believe there are a few useful things in comments that are going to help you predict your affinity card, okay? And then it finds the same thing in household, years of residence. So it's telling you there are a few things that are interesting that we might find in these different columns and attributes. But now going back up here, when you look at the model now, the model themselves have a specific analysis of the importance or of the impact of each of them. So let's click on the naive Bayes. So you click on the model name here, it's a link. When you click on it, you see now the prediction impacts of the model itself. This is using a feature importance component that is running for every model. So now every model now is going to get their own prediction impact. And this is basically telling us, okay, now for naive Bayes, comments were really important. Then we have household, and then occupation, years of residence, instead of being as important as we thought by themselves, right? Years of residence is the fourth one here. Again, very likely because when you mix columns and attributes, you're actually picking up parts of the others, right? And so there might be something about the years of residence that actually is part of the mixture of occupations and household size, something like that. So all of these are things that the machine learning algorithms are going to find, okay? So again, the first things that we did, we looked at the global feature importance of the variables, and then we went and clicked on the naive Bayes model itself, and then we're now looking at the prediction impacts of those attributes, okay? So this is a model agnostic functionality that Oracle Machine Learning includes. We call it MLX, right? Or machine learning explainability. And basically that's how we look at that. Now we can click also on the confusion matrix. So if you go back there, we can click on the confusion matrix here. And then in here, what we're gonna see is what was the number of people that we predicted were going to accept my offer versus the number of people that actually accepted my offer, right? So I had 212 people that I offered and would have accepted, right? Then this is using the test, right? A test or set or a validation set that the AutoML uses at the last step, right? And then we can see that 63 people that I have predicted would have accepted that offer didn't actually accept the offer, right, originally. So on the other hand, there are 32 people that I would not have seen. My model was unable to detect that these guys would have accepted the offer when they actually did originally on the test set. So these are the trade-offs, right, that your model is going to be doing. So if I try to increase this number and push them all the way here to add more people that accept the offer, I might suffer from adding also a lot of people that would not have accepted the offer. So then I end up having to do more mail, right? Just to gather. So the problem here becomes, if I want to add, 10 more people like these, I might end up having to bring a huge cost of 50 more people that wouldn't accept the offer, to the point where that's not useful. Okay, so that's our confusion matrix and the prediction impacts for that model. Okay, any questions so far? So I see there's one question about how the attribute importance is calculated. Yeah, so we have all those details in the documentation. I'm going to show you guys at the end a link, so you can go there and we got the documentation information about that, and the MLX and things along those lines. Okay. Another question was, if you select more accurate when starting the experiments, if there are more predictions or runs of the naive Bayes evaluation. Correct. Yes, the idea is that when you select more accurate, then we're going to evaluate more. So the hyperparameters we're going to be looking at expands, so that you see more options and more specific levels and deeper levels of each model as well. But then there's a trade-off, right, in terms of time. So it's going to take more time for that. Why is the confusion matrix not giving percent results? So thank you for the question. Yes, that's in our roadmap right now. So that's our next step on that confusion matrix. So we're going to go with percents as well, so to make sure that it's much easier to read. What is the training to test ratio used to create the partitions? Yeah, so part of that is in documentation. You can also select, and that's going to come in the OML4Py AutoML, the code. You're going to be able to select, for example, the cross-validation number there. But in the AutoML UI, we use a smart default. So we try to use as much as possible everything that we can do with smart. And that's why even the adaptive sampling is running there to check whether we need a sampling, or the problem might be too small. You don't want to do that, or we want to make sure that we adjust it. Okay. So we have more details on documentation as well. Another question is whether we have control of choosing the grid search parameters. Yes, so we're doing a k-fold validation, but you have that control, but not in the UI itself. So we have that control in the code. So probably as an enhancement, right, as customers use it more and more, then we're going to get more people asking for more control, perhaps, from the AutoML UI, so that we can probably add that in the advanced section. But that's a good question and a good tip as well. Another is, when can we expect time series in AutoML? Yeah, that's something that we are trying to work on as well for later this year, but we don't have a timeline as of right now. Okay, so I'm going to start then lab 2. So basically, we're going to create an auto-generated OML notebook from your first model. So what we're going to do is want to go there exactly where we were in that screen. We're going to select the naive Bayes, and then we're going to click the Create Notebook. Okay. Then when you click on that Create Notebook, a pop-up window is going to come up, and then you can click on Notebook Name. So AutoML Naive Bayes Affinity Prediction. Right. Let's give it that name, and then we're going to click OK. And once you do that, you're going to get the notice on the top that confirms that the notebook was created successfully. Okay, so let's do that. So we come here. If you click on it, you see that you have a shade of blue, right? If you click outside, it's okay. But if you click again on it, it deselects it. So make sure to click not on it, right, but around it in that row. And then we're going to create notebook. Okay. And then we're going to go with AutoML. Let's give it naive Bayes, right? Affinity prediction, right? So AutoML naive B affinity prediction, right? And then I click OK. And then that notebook shows up, and then it says on the top here of the screen that it was successfully created. Okay. So Once that happens, we're going to go to that notebook and take a look. So let's click on the hamburger menu on the top left corner, and let's click on Notebooks. Okay. I'm going to go here in the top left corner and then Notebooks. And we see the notebook over here. Okay, so let's click on it to open that notebook up. So you're going to see a starting notebook server. Okay, that's the message you're going to get. So click on the notebook to open. And what we want to do in the top of that notebook is, because it has not been run yet, right? That notebook shows up and it's all built up for you, but we want to click on the play button so that we run all the paragraphs. Even in the always free account, right? That should be okay. So the idea is then the first section that we saw has a metadata about it. The second part builds a data set the way that the model needs that, right? So we're going to do an import OML. This is our Python module, right? So the OML4Py, we import OML, we set up the columns, the schema, the table name, you guys remember. Then we build that query, right, using that input data set. So we're only using the columns that actually were deemed important by that model. And then we build that data set, and now we show you the data, right? So the data visualization is something very simple. You can see that customer ID, and then you can see the few columns there, right? The second step is splitting the target column, right? So Python has a requirement where you need to have the Y separated, right? You need to have the target column by itself, and then all of the rest of the columns in the as an X, right? As your training input. So that's what we're doing it for you. And then the next steps, we're going to run and build a naive Bayes model. Now you can see that because of the AutoML UI, it determined and created already all of these specific settings, right? So I did not input any specific settings, right? The AutoML UI added these settings to tell that there are some specific hyperparameters that were determined by AutoML UI to make sure that this is the best one, right? So class weights off, and then there's pairwise threshold, there's ODMS details, ODMS sampling, right? So there are a few things here that naive Bayes has as options that the AutoML UI, looking at the hyperparameters, tells me these are the best ones for you. So it wrote that for me, right? I did not have to do anything. So if I run it, it's going to do build an object, right? A naive Bayes object with these settings, and then it fits that model to the X and Y to the data, okay? So finally, after that is done, you have, if you scroll down, right, inside the paragraph, you can see the algorithm. So it shows you the model details, so you can see the algorithm. Inside this section, you can scroll down to see more details about that model. And then finally, we have just a notice saying, you know, for scoring now, inside this current paragraph, we don't have a scoring data set, right? Because we only created one training data set, right? That's the only thing that AutoML knows exists. So it will use the same data for prediction, but you could add a new thing right here in this point by saying, you know, my scoring data equals, and then you give it a new table, and then you can then continue with the rest of the process. So the rest of the process, you have a prediction. Now this guy is running a prediction with the predict, and it's going to select only the prediction column, and it's going to pull that into local memory, because on the next step, we're actually using scikit-learn. It's an open source Python module, right? We're going to use a scikit-learn Python module here to use the metrics balanced accuracy score so that we can show that exactly as the one you had before, right? When we looked at it at the model back in the listing of the AutoML UI, this paragraph actually is showing you that function. Now, this is slightly different because this one is computed over the entire prediction data set, right? So the entire training data set. The one showed and displayed in AutoML UI was built using the validation subset, right? Or a cross-validation subset generated right there. So it's a very slight difference, but it's going to be in the ballpark of that balanced accuracy. okay? In the PDF, you're going to see also some more details. I am adding this there for you so you guys can try it when you come to this point, which is the code that you can use to now not necessarily bring it to Python's memory, but actually this is a code that allows you to predict on that data. You can add the proba equals true to add the probability. So I'm looking at the prediction, but also the probability of that prediction. And then a supplemental columns, because you don't want just the prediction column, right? You really want the customer ID or something else to be able to join this table now with your original table, or you're sending this to the marketing people so they have a customer ID and the prediction, right? So this is the way to do it. Very simple, straight supplemental columns, and then you can put whatever columns you want there. Okay. So Sherry, maybe you can copy that that code as well and paste so that folks can see it and they can copy locally as well. But that's again, that's in the PDF, right? Then the second option is, instead of using predict, is using predict underscore proba. So what that does is that actually then, and you see I don't have a proba equals true here anymore, because this guy is going to show me one probability per class. Okay, that's important because normally what you want to do is you don't want the probability of the highest of the probability of the predicted, right? You actually want the probability of something. So in my case, I'm interested in probability of the guy responding. So if the probability, if the prediction is 0, right, the probability of the guy responding is going to be very low. And normally that's what I'm looking at, right? I'm trying to find the probability of 1. So probability that this guy responded positively to my campaign is going to be very, very low. So then I can discard this guy and move on to the next one, which actually has a 60% probability, right? So so this way you can see multi-class problems. You can have probability of low, medium, and high, probability of 1, 2, 3, 4, whatever your classification is. Okay. And then Sherry, if you can share also that this script, I think you can share the three scripts we have, right? We have the last one here, where now we have the top attributes. So the top n attributes, right? This script here also adds these top n attributes. And I'm back to the predict, okay? Not the predict proba, but I'm back on the predict, so that what's happening now, and the only supplementary column I want is customer ID, because now I have customer ID, I have the prediction, I have the probability of that prediction, and now I have the top 2 attributes that are determined as reasons why this customer has that probability and that prediction. And this is very critical, right? Many people are going to ask you, okay, your model is giving me that probability, but why? And this is the why. With the top n, I can tell you, the first, for this customer number 100, the first attribute most important to determine that it has a high probability of buying that is in his comments. And this is his comments, and this is the weight on those comments. The second column is the household size, which is between 4 and 5. And this is the weight for that column, that attribute now, that helps me determine that this customer is going to buy. You can add more here, of course, and you can add a longer list. And you can see this guy takes more time than if you run it, it's going to take several more seconds because it's doing a lot of more work to get this XML file back, right? There's an XML portion in here. So the second customer here is not going to buy with 100% probability based on this model. And the reason is because in the bookkeeping application, he has it. So he's a 1. It's a good weight for him. And in his comments, he has another type of comment, which is second weight here. So these are determining that the guy is not going to buy. So this is extremely useful for any marketing campaigns, anyone that needs explainability on the why the customer is going to buy. Okay. Okay, so I'm moving on now to the deploying that model with REST APIs. Okay, so if we go back now, lab 3, we go back to our list of the models, right? So to go back to our experiment, we're gonna go right here in the hamburger menu and AutoML, okay? And then we're gonna click on our experiment. This is the already completed experiment. So we're gonna click on it, okay? So I wanna click on the model again, and I'm gonna click on deploy, okay? So now to deploy that model, we're gonna now give it a name, okay? Something like naive Bayes underscore affinity pred, right? Something like that. We can do the same thing for our URI. And then we can give it a version number, right? So for us, is the first model we're registering, model number 1. We can give it a namespace. We're going to call it namespace OML models just to make it easier on us. And we can use shared. You don't need that right now because you're the only ones on this PDB, right? On each of your own PDBs, you might be the only one. But if you do shared, you're going to be able to share the models with other people. So I fill that in and I click OK. And this guy is going to go and say that the model has been deployed successfully. Okay, so if you see this, this is what we want to do. In the instructions, you have the name of the model. I'm going to give it a URI, version, namespace, and then shared. I'm going to check it out, and then I'm going to click OK. Okay, and then I see that it's going to be the selected model was deployed successfully. Okay, so we're now going to take a look at the models themselves. So we click on the hamburger menu and we go to the models menu. Okay, so right here we're going to click on the hamburger menu and on the models menu. So we see 2 models. Why is that? Well, because our AutoML UI created 2 models. Remember, we created a naive Bayes and the GLM was the second best. So it's still created. It's still part of the models here. Okay, so these are the model itself, and you could deploy them from here as well. So when you select them, you can actually click and deploy the models. But let's take a look at the deployments. Okay, so this is the model that was deployed. So I only deployed the naive Bayes so far, right? It's shared. This is the version of that. This is the namespace, and this is the owner. And this is the date, right? That I deployed them. The deployed model here, when I do that, I can then click on that model. So I can click on the deployment, and what I'm going to see is actually the basic features of that model metadata. Okay, if I click on the naive Bayes model here, this is what I see. Okay, so I see that the model is a classification. It's a naive Bayes. These are the attributes the model is using. And if you scroll down, this is the output. It's a categorical output on an affinity card. And these are the labels, 0 and 1. Okay. Now, if you click on the right-hand side, on the URI itself, this is what we see there. We see the entire open API specification for that model. So now here, you even have the URL for the deployment. You have all the information about that. Basically, this is a Swagger file for that model. You have all the information and that REST endpoint and all of the details. So other tools can easily check that model and they can inspect this REST endpoint and they can get that information back for you. When you're developing an application, you can easily query the model and check all of this information about that model. Okay. All right. So let's create a new experiment then with a larger number of models and check a different type of model metric. Okay. What we're going to do now is we're going to go back to AutoML experiment. You're going to see your first experiment there, but we're going to click on create so that we can add a second AutoML experiment. Okay. When we create the second AutoML experiment, we're going to input the same data set, okay, the one that we already used. And this time, the only difference we're going to do is 5 top models, and we're going to change the model metric to recall weighted. Okay. So hamburger menu again, AutoML. I'm going to create I'm going to call it second AutoML experiment. I'm going to add my own data source here. I click on SH, scroll down, and supplementary demographics. Okay. So we're going to say, okay. Same thing again. We're going to select the affinity card. And if you don't want to scroll down, you can start typing. Okay. So if you start typing affinity card, it shows up here as well. Okay. So that helps a lot. And then customer ID. And now we're going to expand the additional settings. And as we mentioned, we're going to leave that 5 as 5 top models. Change the model data service level. Medium is fine. You can put high as well. And then we're going to go and change that to recall and weighted. Okay. And we're going to now start our second experiment. Okay. And we're going to click faster results. Okay. So as before, when it's running, it's going to say starting, and then it's going to be running. And now that it's running, you can check the little 3 dots here. So algorithm selection is still running. Now I've selected the top 5. So it's going to be thinking more. And now it gave me random forest as the first one here. Decision tree, GLM with ridge, support vector machine, right? Linear. So it's showing me that, and it's running all of those. And remember, this is not, you don't necessarily need to be here. So you can go back. You can click on experiments and go back. It's just going to say it's running here. Okay. So it's asynchronous. It's not going to be, it doesn't need you to be looking at it to be running. So we can go back in there at any time and click on the 3 dots. So now we got model tuning happening, right? For the random forest model. So we'll leave that guy running, and we're going to come back to it. Okay. And it should take around 4 minutes or so. So it's going to be fine. So we're going to leave it running. And then basically the idea here is that this is what you're going to see, right? The progress report. And then when it's done, it should take around 4 minutes to finish. And this is what you're going to see. So now we're going to see that the random forest is the top model there, right? So we want to click on that random forest model when this is done. And then we're going to see that the prediction impact is there. So it differs a little bit from the other naive Bayes model. Remember that naive Bayes model was using years of residence, right? It found years of residence as important somewhere over there. But this one is not using that as the top ones. And then you're going to see the confusion matrix as well. So because this is a recall one, this is going to take more heavily a push into this side, right? So it's going to say, okay, I'm not caring too much about people, being left behind. I want to increase more here. Those things are useful, right? You actually, at the end of the day, what we want to do is we want to test, right? So we want to test recall. We want to test the different types of models. What do they do, and how they deal with the different metrics that I'm trying to identify as the best ones for my problem, because it really depends. If you have a problem that you're solving that is marketing based, then you don't mind giving a few coupons to people, as long as you capture the big tickets, right, of people that are the purchases or people that are going to buy your product. If you're trying to avoid fraud, then maybe the 36 people that you didn't target or didn't identify, these guys might be critical, and the cost for that fraud for you is going to be higher than the cost of impacting some customers that were actually doing legitimate transactions, and you just stopped them because you thought they were fraud, right? So there is some insatisfaction balance between the people that are not satisfied because you stopped their transactions from happening when it was not a fraud, compared to the people that were actually doing some fraud, right? So things along those lines. So these is really a balance at the end of the day. So we can deploy that model as well. Same thing, rf underscore affinity underscore pred, once the model is ready. So if I go back to my set of models, my models are done. I can close my summary here, and I can click on that on around the area, right, of the random forest to deploy a model. And I'm gonna call it rf underscore affinity underscore pred. And then I can give it a URI, something simple. This is my 1.0 version of this random forest OML models. And I can say this is a shared, right, model. So same thing again. And I can, or actually I can just even call it a 1.1 model, right, version. It's fine. And I can say, okay. So I'm now registering that model, and it gets registered, right? And I can create a notebook as well. So I can go back here and create a notebook out of that guy, and I can call it AutoML RF affinity pred, right? So so then I can create that notebook. So the same thing applies, right? If I go back to my steps here, then, right, I can check that now the notebook will look like this. And when I run it, or when I look into that notebook, these are the optimized hyperparameters for that random forest algorithm that was determined to be the best one. So you can see there are very different types of parameters, right? Because they are unique to each algorithm. These are the hyperparameters determined by AutoML to be the best ones for this model. Now let's run some AutoML in OML4Py as comparison, right? And I think we're gonna end up with this lab 5, lab 6 gonna be, you can do it yourself. And I highly suggest you guys to play with that. Let's take a look at lab number 5. So for lab number 5, what we want to do is we want to make sure that we go back to that workshop where we were before, right? To this workshop here, and click on the Open Workshop Instructions in a new tab. You're going to see this one. This is the Oracle Machine Learning for Python lab instructions, okay? In there, you're going to find that there is an instruction on how to download the notebooks. So what I want you guys to do now is, Sherry, if you can please put this in the chat. I want you guys to download all the labs notebooks in a single zip file. So the Oracle Machine Learning for Python hands-on lab notebooks, okay? So in the chat now, you can see there's a zip file that I want you guys to download. What we're gonna do with that is, that contains a set of notebooks that I want you guys to load. So when you go back to the notebooks, right, you're going to see the list of notebooks you have. You're probably going to have the second one if you created that, right, with the RF. And we want to click on import. And the zip file that you guys unzipped on your own machines, you're going to see that listing of JSON files. And I want you guys to load them and import them. It's going to say 6 out of 6 notebooks imported successfully, okay? So I'm going to do that right now from here. I'm going to go to notebooks. I got the 2 notebooks I already had, but I'm going to click import. And I'm going to import the 6 notebooks that I gave you guys. Click OK. Okay. And then these guys are going to be there. So these OML, these zip files are available in our GitHub as well. Okay. So all of these 6 labs for OML4Py are there. And we're going to include links to the current lab that we're talking about today right now. So what I want you guys to do then is click on the lab number 6. That's the lab we're going to look at. Okay. Lab 6, use AutoML. Okay. So we're going to click on lab 6, use AutoML. In there are a few sections. Again, we're probably not going to run out of time before being able to run everything. But I want you guys to take a look at those guys and understand what we do there. So with OML for Python, you can run all of the specific sections that the AutoML UI was running. You could run them manually and do your own selection of steps. again, AutoML UI is going to be a nice complement. You can start there. Is all UI. There's no programming needed. Click a few buttons and then you can run it, right? In here, I'm showing you an under the hood version, right? With OML4Py, you can look into more details, right? So I'm not going to run it because again, we're running out of time, so I don't want you guys to, I just want you guys to see it, but you can check it out when you scroll down. So AutoML, you have a few sections, right? The first section is going to be import libraries. So we're going to import those libraries. We're going to use an OML sync function to create an OML data frame as proxy, right? So we're loading that wine data set. We're going to then run an automated algorithm selection, right? So when we run that, the algorithm selection function right here, right? AutoML algorithm selection is going to basically select the best algorithm based on your data. So we're saying classification. Remember the scoring metric, same thing here. And we can give it a parallel. So if we have availability for parallelism, we're going to get it. And then we're going to run the select function on top of that. We're going to pass our X and our Y, right? Our target and our input attributes. And then we're going to say how many algorithms we want to see. Remember that we did that as well. So when you get back here, this is what it's going to tell you. You got the SVM Gaussian model as the best one. You got the SVM linear as the second one, neural networks as the third one, and random forest at the fourth one. Okay. Remember, this is just to tell you these are the algorithms that were selected to be the best. These are not tuned yet. These are not feature selected yet. So what we can do is now run an automated feature selection on the best selected algorithm from here, which we're going to use a function here to just capture that. So this is just a string with the name SVM Gaussian, okay, to capture that best algorithm, right? So this string we're going to pass into our feature selection here, and we're going to say this is the best algorithm we want to use. So we're going to run a feature selection on it. So now we pass the original X and Y, and it spits out our reduced sets. So it says, I reduce it from the original 13 attributes you gave me to 9. Okay. And these are the selected columns. And now the final step is automated model tuning. So now that I get my selected algorithm, I'm going to get that selected algorithm again, but I'm going to pass the reduced set of attributes. And now I'm going to tune that guy, right? So you're going to tune that algorithm there. And this is now the result. So this is the final model. As I mentioned before, you got to scroll down inside here so you can see that there's an SVM classification, and you can see a little bit of the attributes that that model is using, okay? And finally, our finish, to finish it off, right? You can play with hyperparameters. So this is showing you how to check all the evaluations that were done, right, by that tuning. So it's telling you these different types of evaluations that were executed. And then we can run down here our own search space. So we can determine the search space for these hyperparameters, okay? So you can put your own here selections. And then I'm running this for the random forest, for example. And then you get that classification back there, right? At the end of the day, we have something called the automated model selection. This is different than the algorithm selection. The algorithm selection only checks between algorithms. The model selection is going to do everything for us, okay? The model selection is doing what AutoML UI is doing, basically. So it's actually, I give it a set of classification functions. I give it an input attributes, the target, and it does everything for me. It will do the model selection, the feature importance, the feature selection, and the and finally the tuning as well. So it spits out one model that is the best one at the last output here. Okay. So we are quickly arriving to the end of the time we have allocated. So what I wanted to do with you guys for a next session, this is a bonus section. So if you guys want to check it, it's again on the PDF. It goes through how to deploy the model. Now that you deploy the models, how to score with it, right? So it was going to show you about OML services. So we talked last week's session and all the different methods that we have. And then the portions of how to download Postman, how to install it, how to get it going on your laptop, how to configure that, and then where to download the components, the examples that I created. And then in here, you're going to be able to actually run the scoring. So with that, you were going to be able to run a scoring with it, and then show you how to do that, right? So in the, you pass that to your database, and you get a token first, right, out of that. And then after you get your token, you can, you can change that portion of the post command here with your own model, the name of that model you registered. You get these input records that were already there on the section 313, and then you're going to be able to predict. Click the prediction in 200 milliseconds. The first time, 260 milliseconds, you got the predictions out, right? And you can visualize them there. So that is for your bonus section. So if you guys wanted to try it out, it's all in the PDF. And where to go from here? We got the AutoML UI has its own documentation. So we have documentation about it, information about how to get started with it. We got helpful links as well. Again, these are all in the PDF distributed to you guys. And then other Ask Tom sessions. So we got our office hours coming up. We had Machine Learning 101 sessions and from the end of 2020 all the way back to May 2020 when we started the 101 sessions. Next week, we're going to do a hands-on lab on machine learning for Python. So if you guys are interested, please join us. And in GitHub, you're going to find everything that we're saying today, all the OML4Py hands-on labs, OML services demos, everything's going to be there in the GitHub as well. So if you guys want to check it out. Okay. So I'm going to stop and open up for Q&A if there is any more Q&A. I know we answered several questions during the session, and Mark and Sherry, thank you very much for answering all those questions. And if you guys want to, I'm open to any questions. Mark and Sherry, any other further questions?
I think we've got one outstanding one, Marcos. It's how do you generate global feature importance in AutoML UI?
Oh yeah, excellent question. So that is part of the process. So we are using behind the scenes a combination of our own component inside the Oracle Machine Learning. So we have our own feature importance that we run. That we have further documentation of it directly in the MLX model. So you can see the global feature importance in the MLX module, in the documentation of the Oracle Machine Learning for Python itself. But in AutoML UI, we are just using that function and show it to you. So right now, we don't allow you to say change or make changes to it. Maybe in the future is something that we might look at. So if you have a specific thing in mind that you would like to do, I encourage you to send us feedback, and we would love to work with you on that.
Yeah. I mean, as you mentioned, Marcos, there are a number of different techniques that are being used for this. And so, the machine learning has a capability called attribute importance. So it uses a minimum description length algorithm for that. And you can use that directly just as an algorithm in the database. And that's one of the techniques that are being included with this. And then there are, I think, as Marcos said, there are about 4 other techniques that are included that contribute to the overall ranking at that level. So we'll be including that in the documentation as well.
Excellent. Any more questions? Okay. So thank you guys for joining. We're gonna again distribute all of this information, the links, the PDFs, the links to the zip files. Everything is gonna be in the Ask Tom. So if you go back to that same links that you used to get here today, you're gonna see now after we process everything that you're gonna get the links to the zip files and collections and things like that. Okay. So thank you very much again, and have a great rest of your day. And thank you, Mark, and thank you, Sherry.
Our pleasure.